Here's some pictures we've gained over the years. There are many different situations we've gotten into and fixed, and hopefully they're really helpful to you to diagnose what you have. If not, you can always give us a call or email us. Thanks. These slats are excessively wore. As you can see to the left, there's a crack developing in the top face of the slat also. There I would investigate, and what I mean by that is taking a light and shining in that opening to see if the bottom of that slat has fallen off. And then the other thing that I noticed here is the openings are starting to open up too, ever so slightly. There would be a animal health issue or a leg issue potentially. Here again is another excessively worn slat. As you can see on the bottom, in the middle, there's no cracking, but it's just excessively worn. Typically, they don't last as long as a good slat that doesn't show wear like this. Here the slat again is excessively worn, but there's also a chunk missing out of the middle rail. If you look closely, you can see the rebar is actually placed off to the left. It should be centered typically, and you can see the crack develop in the face of it above. That's why I always say if there's a crack developing like that, typically there's a structural issue with the bottom of the slat. You can see the next rail to the right of it, there's another crack developing. I would expect that to be a problem as well. If not the bottom falling out of the slat, there's a crack developing in the side of the slat. There's excessive cracks in this slat. They run not only horizontal but with the slat. The one that's in the top of the rail is a huge concern, and the one that travels from left to right. I would inspect that further with a flashlight or with your hand. You can feel to see if there's cracks in them rails in that situation. Here is a looking down in the opening, you can tell that it's cracked, and actually part of the bottom is fallen out of the slat. Like the previous slides, there's examples of cracks in the top. This is typically what you would see with the crack in the face of the slat. Here's a good representation of the crack in the face of the slat and the bottom of that slat separating. The reason for that is that rebar is starting to rust and swell, so you almost have like a freeze-thaw effect. So it's fracturing the concrete at that point. Here again, another example. It's a little bit more severe with the face of the slat cracked. Chunk missing off the bottom of the slat if you look to the right, and then the crack travels all the way from left to right through the bottom of that slat. See two different slats. The slat on the top has no cracking issues, but the slat on the bottom has severe cracking issues. That rebar that's placed in the end of that slat is starting to rust and swell. And it's starting to break apart. Here's a picture of that last slat that had the cracks in the top of it. After we pulled it out, you can see how the end of it is totally split and it's starting to fall apart. We had to cut the slat in half. There were some random replacements going on in that barn, so we just cut them in 2-foot pieces to remove them and put the new ones in. You can see the beam is cracked through the middle by the dark area. If you look from left to right to left, the crack is more severe on the right side, but that beam is absolutely no good. It's seen its useful life. Here we replace the slats and beams with new gangs and brand new beams. This, I believe, is in the same barn as the last. You can see where the rebar is actually showing, and if you follow the rebar to the right, you can see how severe it's cracked even at that location. And then it's a good representation of the beams being properly placed. You can see the seam centered on top of the post, but then the beam to the left has a crack in the bottom of it and the top of it also. This barn, we totally replaced the slats and beams in it. Showing where we had pulled slats off the top, and you can see the beam farthest away from the photo. The rebar is exposed all the way across there. I think what happened there was, in manufacturing it, that piece of rebar was too close to the edge. That's why it's exposed like that now. This is a very good picture of how I inspect a barn or look at a barn. Taking a flashlight, shining in that opening, you can see the cracks that are developing in that beam. Typically I look farther back with the flashlight, looking for a straight edge along that bottom of that beam, and then also looking for cracks that might have developed an inch to an inch and a half up from the bottom. That is the most common. I get a lot of questions asked about sagging slats. This particular barn, there was actually 3 inches of sag in the slats. You can't quite tell it here, but it's very severe. Probably the most severe one I've ever seen out of all the work we've ever done. Here again is another picture of the same barn. You can tell a little bit better actually how much the slats sag. If you look to the right, you can see the gates have actually bent because the slats sagged. I believe that the slats were green when they're installed, and if you look in the middle under the O in Altenburg construction, the first O, you can see that the beam is actually cracked as well. There's a couple cracks, and if you follow it to the left, there's a crack in the bottom of that beam underneath the U in Altenburg. Number 16 is just a representation. Some of our competitors claim that they can go through a walk door. Here we entered through a curtain and actually cut part of the concrete wall out. You can see that, yeah, we put the barn right back where it was. We've done this thousands of times with no problems. In my opinion, going through a walk door is honestly a bottleneck in the situation, and it just creates more problems and headaches because you're handling the slats the way they're not designed to be handled. They're not designed to be turned on their sides or handled that way. Here's a picture of a beam that is actually way too far off to the edge of the post. It's on there less than 3 inches, and by rule of thumb, any slat manufacturer should tell you or would recommend that you have at least 3 inches of that beam bearing on top of your post. Here I would say it's only about 2, plus there's a couple cracks in that beam as well. It's just the starting stages of more severe cracks. Even a more extreme case of a beam not setting on the post properly. It is only on that post by 1 inch. This is one of the really common things we find in barns built from the 90s and 2000s. We fix this situation probably 80 times a year. And here again, it's hard to see, but it's the same thing where that beam wasn't properly set on the post and the beam is dropped, and the farmer called instead I'm tripping over this slat all of a sudden, and I never have before. I kind of call them toe kickers, and it's a easy fix at this point. The other thing, in this picture, you can see the grout line as well. It's excessively wide. I don't believe there is 2 inches of that slat sitting on top of that beam either. When your grout line gets to be over 5 inches wide, there's only the face of the beams are typically 9 inches wide, depending upon the manufacturer. So this grout line should be removed. The slat should be moved over to bear at least 2 inches on top of that beam or your slat ledge, and more than one grout line should have been used in this situation. You can see how this slat failed, but if you look off to the left, there's a crack through and through in that next slat. That one isn't too far behind what this slat actually did. There's an all-out failure. What I believe happened was a beam failed and all the slats fell in, and in this particular situation they had concrete fences. That's what you see laying on top. And also in this situation, the slats go from sidewall to sidewall rather than the length of the barn, and we were able to change the direction, so we actually laid the slats in there opposite the way they sit now. These slats were 12 footers. We ended up putting a 12-foot beam in there and then actually putting 10-foot slats in there the other direction and running the beams the length of the barn. Here's a gestation barn that had a beam failure. Basically the gates are holding that stuff up yet from it either being pinned together or bolted in the slat. It's just one of them things. You just need to investigate your floor either on an annual basis if it's getting to be an older barn, and what I consider an older barn is 15 years or more, because there's some product out there that unfortunately got made improperly or poorly. But on a good floor, your floor should last roughly 30 years, I think. There was no concrete beams in here. They actually used steel I-beams, and over time they rusted and had failed. This is a prime example of poor quality control, I think, in manufacturing slats. I don't believe this manufacturer is in business anymore. There was 1/3/8 rod put in this beam, and that obviously is not acceptable. This barn is it had been completed a month prior, I believe, and this was the first turn of pegs put through it. We ended up changing all the slats and beams out of here, and had found other product in there that had little to no rebar in some other pieces. Here's a post issue, which is very rare. You can see on the back corner of that post that it's chipped out severely bad. The other thing you'll notice is this beam on the left has a crack starting to develop in the corner. That's nothing to get concerned with as far as it failing, until you see a little bit worse cracks, some separation or rebar exposed. At this point, we did replace the entire floor because there was a lot more issues going on with this floor as well. This is excessively worn around the feeder pads, which is pretty common nowadays, it seems like, because of the feed ingredients and especially the wet-dry feeder like you see in the picture. Here's just a different angle of the same feeder. It seems to be atypical that it, goes out 1.5 to 2 foot all the way around, and they even tried to pour a concrete pad around the feeder to help it out, but it seems to just push the problem, out to the slats. This here is poor construction, in my opinion. There's only a 1-inch slat ledge, and like I said before, you need a minimum of 2 inches of either a slat ledge or 2 inches of that slat on the beam or slat ledge to bear that load. All manufacturers would tell you that, simply because that rod's placed within an inch of the end of that slat typically, and you need that rod over that bearing point to carry the load.